Hello everybody! In the previous video we talked about writing our hasRepeat function that takes an input as input a vector v and it returns true if there's an element of v that appears twice. So what we're going to do in this video is we're going to be timing this function and we're going to be timing it with vectors that kind of have various different lengths, and then we're going to be plotting how long it takes to search each of these vectors. So if you remember back to when we introduced tick and talk, so the timing commands, the kind of searching that we did in that video, we guessed that it kind of had linear behavior. So for instance, if I increased the length of a vector by 10, then the time would also increase by 10. But here we're going to see an example where the behavior is nonlinear, so let's get into it. So again, I already have this hasRepeat function defined. What I'm going to do is I'm going to create a new script. And first thing I'm going to do is I'm going to create a vector of different lengths. So these are going to be the lengths of vectors that I want to test. So let's say I start with a length 100 vector. Let's say I go up by 500 and don't go past 20,000. If these numbers seem random, it's just because we already know that this is going to create a nice plot in the end. It's going to be kind of nice to look at. So those are the lengths we're going to go with. Now, eventually I'm going to want to plot. So want to plot x coordinates to be the lengths. So I want to have a plot where the x coordinates are lengths and the y coordinates is the time to search, for repeats. So what I'm going to do is I'm going to start by kind of initializing x and y to be empty vectors. And what I'm going to do is for I equal to the lengths, so it's going to say first let's kind of consider a vector that has length 100, then 600, and then just keep going on, then 1100. And so we're going to go for I equal to lengths. Then I'm going to say, remember, I just want the x coordinates to be the lengths, so I'm going to say x is equal to x comma I. Then what I'm going to do is I'm going to type tick because now I'm going to search the vector. So, and I guess I haven't kind of created, actually, no, this is okay. So what I'm going to do is I'm going to say tick and then b equals hasRepeat of, now I need a vector that has length I. So I'm just going to do the easiest thing and say create the vector 1 to I. Then remember we want the y coordinates to be the time to search for repeats. So I'm going to say my temporary variable is equal to talk. That tells me how long it's been since tick. Then I'm going to say y is equal to y comma temp. And I'm going to end the for loop. Oops, and I'm missing some semicolons. And finally, I'm going to say plot x comma y comma. And again, just because I've done this before, I know that it's going to look nice if I plot it with x's and the x's are black. So let's save it. I'm going to call this as hasRepeat time. And let's run it. And this might take a little bit of time just because, so remember we're going through all of these kind of different lengths and it's going to take some time for it to search each of them. But here we can see that the behavior definitely doesn't look linear. So kind of remember the x-axis is telling us what is the length of the vector and the y-axis is telling us how long did it take to search it for duplicates. And basically here definitely doesn't look linear. And remember this kind of, you can think of it going back to the fact that how many pairs are we checking? Well, it's approximately n squared over 2 pairs. Another thing that I want to draw your attention to that I didn't emphasize enough when we were writing the code is notice here in this b equals hasRepeat when we're creating this vector 1 to I. So some of you might be saying, wait, hey, that vector doesn't have any repeats. And that's kind of the point, because when we're testing our functions for time, we always want to consider what's the worst case, what's going to take the longest. So here, there's no repeats, so the code is going to have to check every single pair, and it's never going to find it, and B is going to be false every time. So that's kind of why we used these vectors, is because we really wanted to measure what's the worst case scenario. But otherwise, please let us know if you have any questions. I think this is a good place to stop, and I will see you in the next video.